Hi there, and a very warm welcome to this week's second video actually. So the first video was about Cinema 4D's new color workflow and therefore how to set it up to match up with Octane and not give wrong colors. This brought up the idea to talk about the actually non-EXR image output that I'm personally not engaged with, but I get a lot of questions how you can get the right look out of it. So basically, if you're going with ACES to sRGB or HEX, so it matches, so your output matches with the things you have in your live viewer. So without further ado, let's talk about this. Grab your coffee and let's jump right in. And welcome to Cinema 4D land. As we used a box in our last tutorial, I thought let's stay boxy and go with dice. Let's have a look at the scene and explain what this is all about, as I have the feeling that this premise is not that easy to understand. As you might know, Octane can engage in more color workflows than the standard sRGB one. The best known example for that is in the imager if you tick the ACES Tonemapping. This will give you the ACES to sRGB tone mapping in your live viewer. As you can see, the result look a little bit more contrasty, and you can see also the oversaturation here is gone with the ACES tone mapping. As this is more contrasty, I usually give it a small boost with a slightly higher exposure, just like this. Of course, this is not the only workflow Octane can engage in. You might have seen the OpenColor.io slot here. This only works if we bring in an external OpenColor.io file, but then basically the possibilities are endless. And yes, of course, I will show this workflow later on, but let's first answer the question why we are doing this tutorial after all. So in contrast to past tutorials where I go over the EXR workflow, those are image sequences that can hold all the data that has been generated while rendering, with the advantage of continuing your color processing and color corrections inside of the compositing stage. What we're going to do today is concentrating on an output that is ready as is and, so to speak, uploadable to the internet right away with the right colors and the right look. Now, if you understood all that, first of all, congratulations, and second of all, if you didn't, then just keep on watching. And if you're going, well, this premise seems very simple, couldn't you just save? Pretty much yes, if you're just engaged in a sRGB workflow, but if you have any other color profile assigned to it, then things are a little bit more complicated, unfortunately. So first of all, let's speak about the different regions in Cinema 4D where you actually can save the image. First of all, if you're just rendering still images in your live viewer, what you can do is save straight through here. So you can save image as and then go with this dialog here. Next, as a Cinema 4D user, you're probably most familiar with that. You can save through the Cinema 4D saving dialog here. And last but not least, the one I use and heavily recommend is the one inside of the Octane render settings. Back here in the Render AUV Manager, you can save your passes out here. If you want to render traditionally and automatically save when the render is done, then the best way to do that is with the Render AUV Manager or with the Cinema 4D output here. But better show than tell, let's have a look at the Cinema 4D output. So I disengage the Octane one, go back to save. Since we are not using a multipass sequence, we just have the one output left. And just to clear things up, when I say ready to upload, what I'm talking about is a 8-bit or 16-bit TIFF, a 8-bit or 16-bit PNG, or even a JPG. I'm going with 8-bit TIFFs for this tutorial. So what I'm going to show here is basically if we disengage the ACES tone mapping here, then you will get the picture that you see here one-to-one in every output scenario. The only thing you need to know when outputting integer values of 8 and 16-bit, so no 32-bit float or 16-bit float, is that you need to go to Octane Render and make sure the color space is set to sRGB. So if you have sRGB locked in and then just hit render, then we overwrite the image that I saved before. You will see that we get exactly the same image as a render than we have in our live viewer. You can see this is matching one-to-one, even with all the flaws that come with the usual sRGB workflow as the oversaturated cyan parts here. As I said, if you're engaged in a 8 or 16-bit workflow, what you don't want to set is anything else than sRGB. So let's try linear sRGB and see what this comes up with. So basically, this is just a linear image or a missing gamma, and also the same as if I go to the roll down here and set this to HDR linear sRGB. This would be the right thing to do for EXRs, but just to be precise and clear, this is not the workflow you engage in with 8 or 16-bit images. You go with sRGB always. As I said before, this is the most simple one. This works everywhere. Let's up the difficulty a bit by going with the ACES Tonemapping workflow. If you're having no multipasses, this also works through the Cinema 4D output. So let's render. And as you can see, we get a matching output again. Very nice. And now the big but with this method, if you want to engage in a multipass workflow, or in other words in an AUV workflow. So what I'm talking about is if you enable this one here to get your AUV's output, this also will enable Cinema 4D's multi-layer output. And if we just change that and render again, you will see that the gamma now is for some reason wrong. So the difference between linear sRGB and sRGB is just a gamma 2.2. So this gamma is applied twice to this image for some reason. So what we could do is go to the filter section, enable it, and then divide 1 by 2.2 and get a gamma of 0.4545 and matching colors again. But this is very tedious. And if I bring in the image that was just saved to disk, sorry for the Windowsception here, this one was saved with the incorrect double gamma. So what we needed to do is save this again. Again, this would be very tedious. Maybe you think you're smart, and probably you are. Let's disengage this filter. So if you think this is a double gamma, so what if we go to our settings here and set this to linear sRGB, so the gamma can be applied to the linear sRGB and then we are cool? Let's do so and see what comes out of that. The answer is that we actually get a correct image, but one where the ACES tone mapping isn't applied. You just have to look at the oversaturated areas here. So with this method, no dice, we are back to square one. And this is why I, no matter what you save, always recommend the Render AOV Manager's output here. This is because this output is directly connected to Octane's core, whereas the Cinema 4D output is basically a handshake between Cinema 4D's saving and Octane delivering the image, which can lead to problems which you already encountered. To make the transition a little bit faster, let me actually save out that render token here, then disable those channels, go back to our output, paste it in here. We don't need the underscore because we already have this here. Now, this would be the right setting for my EXR output. You can watch this in my other videos, but let's go with a TIFF again and then therefore 8-bit. Here we go. As I'm still not a big fan of multi-layer files, I disable this, and as we need to save the beauty to also have it included, let's enable this. I'm just using TIFF to stay consistent. Of course, you are able to also use PNG, for example, or JPG or any other format that's in here. Let's go to main and set this back to sRGB and then hit render one more time. And oh no, the double gamma is back, but this happens between the communication of Octane and Cinema 4D. As you remember, we saved directly to disk from Octane. So if I open up the image, sorry for the Windowsception again, you can see this is looking correctly and has the nice tone mapped colors of ACES sRGB. So unfortunately, the picture viewer is not always to be trusted, especially if we're saving past it with the Render AOV Manager. So with those color workflows, better do a test render and check what arrives on disk. Now, if you really need to use the Cinema 4D output, for example, if you're rendering on a render farm, then I let you in on a little secret. If you go to main, go to linear sRGB, and then check force tone mapping, then you finally are able to get the tone mapping from ACES inside of a normal looking render. Okay, let's up this game a notch again and go into OpenColor.io territory. To get started with OpenColor.io, we need to go to the settings, then to color management and get an OpenColor.io file inside of Octane. The probably most famous OpenColor.io file comes from ACES, but what I want to go with today is HEX. I of course have a tutorial on HEX as well, but it relies on EXRs and compositing, and as we said before, today we want to bake in our looks and therefore be able to just upload the image that comes out of Cinema 4D. To get this started, we need a HEX OpenColor.io file. To get there, we need to open up a web page. So if you search for Mixel Manager OpenColor.io config on GitHub, you will find this page here. The link is also in the description below. So once you hit the page, what you can do is go to code, download the zip file, unzip it, and then navigate to this OpenColor.io config file. Let's do so on our Octane version. Let's use the file here, go to the file, and oh wonder, we are already in the right directory. Let's choose the config OpenColor.io, and if it's loaded, let's check automatic. This will load the color settings for the linked profile into Octane, and we can access them under Imager and then OpenColor.io. We are finally at the stage to toggle the OpenColor.io here, but nothing has happened, and this is because we are still using the standard settings. I hope you don't get shocked by the plethora of options here. Basically, all the sRGB options are the ones that are of interest to us because our screen is sRGB, so we go with the second one here. This is HEX sRGB. Now, this looks a little bit washed out, and therefore we can choose a look, for example, a high contrast or medium high contrast. Now, since HEX is not as contrasty as ACES, what we can do is go back to our imager and set the exposure back to 1. Now, if you still don't like the contrast ratio here, let's go back to OpenColor.io and roll this out again. There's a plethora of settings you can check out. Even beyond the screen you can see, but let's go with the very high contrast for now, as it gives very poppy colors. But let's talk about the elephant in the room. How do we get this image out of here? Now, of course, we could go to Save Image As and get it out like this, but if we want to render an animation or this image in bigger, then we have to use those outputs again. Now, let's real quick disengage the ACES Tonemapping to not confuse it with our current setup, and then render with the current settings here just to show you that it will not work. And you can see we are back to square one with a purely sRGB image arriving at our picture viewer and also at our disk. Just to direct your eye, you can see those colors aren't popping as much, and also those overexposed areas here are oversaturated in our render. There very well might be other options, but the only way I found to get this look out of here and bake it into the image is go with the OpenColor.io setting inside of our color space and basically fit the ones that we just used here. Let's find the equivalent to sRGB HEX here. So let's choose it from here, go down to color spaces, then to imagery sRGB, and then HEX base sRGB. And of course, also don't forget to choose the look as well, which is the very high contrast, like this. And of course, this can't be as easy as just rendering this out with this settings and it just working. By the way, if someone knows what this force tone mapping setting here is doing, please let me know because I couldn't figure it out. Anyway, back to topic. So the only working solution I have found was to go back to the render AOV manager and set the format from TIFF to PNG, because this seems to be the only one that retains the gamma correctly. Again, let's have a render and don't trust the picture viewer, because if we bring in the rendered PNG, it actually has the right colors, the right contrast, and the right tone mapping finally. This is in contrast to when I tried rendering a TIFF. This also has the double gamma, unfortunately. So probably this is something for the developers to fix. Now, I was lying a little bit, saying there is no other way. We have Octane's internal compositing tools, and those also are capable of doing HEX, for example. So as a bonus, let's look at those. And welcome to the next and last chapter of today's tutorial, the internal compositing with HEX. You might have noticed that I reset all the color processing of the scene to sRGB again, so you can see the oversaturated parts here and the dyes are looking normal again. This is because we have access to all the color information in the comp context, which is based on nodes. Let's go there by going to the node editor and then render AOVs. go to the render AOVs, and then go to the output AOV compositor. As I also said in an older video, it's always good to start with a preset if you don't know what you're doing. So let's go with the wire and main here and apply it so you can see what Octane is giving us. As soon as we did that, another output was popping up. So in there you can see what the setup is doing. Now, if I unplug the above node here, you can see we're back to our beauty. So this node here is giving us our beauty, and this one here is the wireframe, which we don't need. What would be very useful here though is an HEX color, and we can give it to it by going to the basic. While this node is still selected, then search for it here. Unfortunately, this is slightly out of screen. It reads sRGB display to HEX. So if we select that one here, then plug it back in, you can see now we have the HEX tone mapping. And if we go to the parameters, you can see there are not that many, but we can choose punchy, and this gives us sort of the right look back. If you understandably are fixed to the look that we just created and didn't want to get it any other way, what we can do is go back to our node and instead of the HEX, go for the Open Color I/O. And then basically choose the same settings that we had before, which is sRGB HEX and then very high contrast. Small heads up, of course, to find those settings here, what you need to have is the Open Color I/O for the HEX still engaged in here. And now, with the internal compositor to the rescue, it's finally time to release out this baked image with the right gamma into the wild. Let's have a quick look at the render settings. So in main, I set this back to sRGB, and in the render AOV manager, I set this back to TIFF to show you that it's working with all the different formats. Also, if you don't want the untone mapped beauty path, just uncheck it here. But I just leave it in, hit render, relax, and marvel at our result. With those render settings, you can see that it loaded back in the final frame from the Octane save, rather than keeping the one that the picture viewer showed. So during the render, it's double gamma, but when the render is finished, it snaps back to the right result. Also, if we go to the layers and go to the other path, that is the out one, we can see now we have the final image with the baked in HEX ready to go. And as a last check, if I bring in the image that was saved to disk, you can see the exact same behavior here, and this ticks all the checkboxes. Now, making this tutorial made me realize that the color pipeline other than EXR inside of Octane and Cinema 4D might need an overhaul. And if you're engaged in this, then at least use the internal compositing, because this is by far the easiest way to get there. Before I conclude this tutorial, a small shout out to my Patreon, where you will be able to download the scene, which has a very nice dice material where I used vertex maps to get all those details inside of it. You can probably use that for other scenes as well. And now let's conclude this video by thanking those people who made it possible. Of course, my Patreons. Especially my €50 tier subscribers, Shields Augustinen and Leon Studio TV. Also, of course, a huge thank you for my €15 tier subscribers, 4D Thieves, Alessio De Vecchi, Ami Schiedried, Christian Grajewski, Graham Bucknell, Grigoris Morikis, Joel Muckemer, John Edward, Chris Clemson, Lucas M. Silveira, Mike Rogers, Mikkel Obenhuis, Ness Graphics, Nico Straub, Part 1 of 2, Ralf, Random Capybara, Raiko, Shiro 2049, Zoo Shag, Terry Wayne Ranson, Jan Verbeeke, and Yassin Rupp. Wow, what a day, or better, what a night, because it's already really late and I'm recording my second tutorial today, and this is the second afterclapper speech I'm recording. So if you're still around, if you're still watching, thank you so much for sticking around this long. It's really funny, I'm lately trying to be an early bird, so someone who wakes up early, but for some reason this is totally against my nature. I'm doing my best work in the middle of the night. The problem is that I feel terrible if I sleep long. Well, what's our life other than a series of constraints and habits? I don't know. Probably it's too late to be philosophical here. So after those shorter tutorials, this one is a longer one. Hopefully you liked it. It's crammed with information. So fingers crossed people will like it. If you're still listening, then you probably did. So thank you yet again. Now let's go with some routines here. So if you want to help me fight the algorithm overlords, then you can post a card file box in the comments down below. With that being said, I wish you a great early week, a good time ahead, and I say happy baking. Bye.